Sir, am I audible?
Yes, you are audible.
Yes, sir.
Yeah, last day we have discussed, last topic is
Sir, electrochemistry was discussed.
complete and left.
Sir, completed. Electrochemistry completed. Conductance part is left, and today's topic were ionic equilibrium and quantum theories and these types of things were today's topic.
Chemical equilibrium we have discussed, left.
Yes, sir, it is left.
Yeah, let me start basic, introduce yourself.
Yes. Sir, I am SubodhCheM. I am from Purbo Medinipur district of West Bengal. I completed my class 10th and 12th from Nachinda Jiban Krishna High School. After that, I completed my BSc from Midnapur College Autonomous. Then I completed my MSc from IIT Guwahati. And sir, currently I am preparing for competitive exams related to chemistry.
Yes, good. Today new topic is chemical equilibrium and ionic equilibrium.
Yes, sir.
Yes, what the main application of chemical equilibrium?
Yes, sir. Chemical equilibrium, it is the application of thermodynamics in which we generally discuss the equilibrium state of a reaction where the equilibrium concentrations, equilibrium constants, the process for shifting the equilibrium towards the left or right, or temperature dependence of the equilibrium constant. So these types of things are discussed in chemical equilibrium, and by knowing the concepts of chemical equilibrium, we can predict whether there will be a shift in the equilibrium if the conditioning equilibrium conditioning parameters like temperature, pressure, and other concentrations are changed. Then the shifting of the equilibrium can be predicted by the concept of the chemical equilibrium.
Yes, solid liquid equilibrium, liquid gas equilibrium, and
And
solid vapor equilibrium. What the difference?
yes, sir. These are the physical equilibriums. These are not chemical equilibriums. In
Yes.
this case, the for solid liquid equilibrium, there is a equilibrium between the two phases. One is solid and another is liquid, and there will be a equilibrium to up to the melting point. In this, the equilibrium temperature and pressures that are controlled by the melting point curves, and this the phenomena is called melting, and the liquid, and from the solid to liquid it is called solidification. And the solid liquid in a liquid vapor equilibrium, then the liquid and vapor are in the equilibrium, one liquid phase and one vapor phase. In this, the curve representing the liquid vapor equilibrium, it is called a vapor pressure curve. And in this case the temperature and pressure are changed, then there will be the change in the equilibrium temperature and pressure also. So temperature and pressure can be controlled to control the particular equilibrium. And also the another is solid vapor equilibrium, solid to vapor equilibrium, it is called the curve representing the solid vapor equilibrium, it is called the vapor pressure curve of the solid. And it is also known as the sublimation curve, and in which one state is solid and another state is gaseous, and the equilibrium is maintained up to the triple point. So these are the equilibriums.
Yes, what the difference between chemical equilibrium and dynamic equilibrium?
Yes, sir. Now, dynamic equilibrium, it is type of a equilibrium in which there is the change in the concentration of the particular species takes place, though the equilibrium is also attained. So these types of equilibrium are called dynamic equilibrium. So the reactions are going on, but the speed of the forward reaction and the speed of the backward reaction both are same. So we do not see any need change from the outside, but there is the simultaneous reaction are going there. That is type is equilibrium is called a dynamic equilibrium. And chemical equilibrium is also dynamic equilibrium. And the another type of equilibrium is called static equilibrium, though there is a the theoretically static equilibrium is like that the reaction should be stopped, and the equilibrium concentration of the product and reactant remain constant with time, but the reaction has been stopped. So these types of equilibrium are called static equilibrium. But we know that from the concept of chemical equilibrium that the chemical equilibrium are dynamic in nature.
Yes, good. Chemical
Yes, sir.
equilibrium is three types. Yes, no? Thermal equilibrium, static equilibrium, and physical and chemical equilibrium.
Yes, sir. The thermodynamic equilibrium. This is of three types. The equilibriums are of three types. One is thermal equilibrium, another is mechanical equilibrium, and third type is chemical equilibrium. In thermal equilibrium, the temperature of the two system or the system with the surroundings becomes same. So then the two system or the system with the surrounding, it will be called, they are remain in the thermal equilibrium. So no heat exchange will take place in this case. And another type of equilibrium, that is called mechanical equilibrium, in which the pressure of the two system or the pressure between the system and surroundings, that will become same. So these types of equilibrium will be called the mechanical equilibrium. If the two system or a system and the surrounding remain in the mechanical equilibrium, then there will be no need work done will be on or by the system. And the third type of equilibrium, that is called material equilibrium or chemical equilibrium, in which the chemical potential of the two system or the system with the surroundings, that will be same. Then it will be called as chemical equilibrium. So chemical potential is the parameter which determines the chemical equilibrium. And if the all three equilibriums are maintained together, then there will be called a thermodynamic equilibrium, that the two system or the system and the surroundings remains in.
Yes, good. Chemical equilibrium is two types, irreversible and irreversible. What the difference?
Yes, sir. Reversible type of equilibrium, that is a type of equilibrium in which the speed of the forward reaction and speed of the backward reaction will be same. So there will not be a need change in the concentration of the reactants or products. And another type, in case of other type, there will be a shift in a particular forward direction. So it will be taken as the reaction is almost completed for the particular reaction.
Yes, good. Next one is law of
Yes.
mass action. What the main application of
Yes.
law of mass action?
Yes, sir. The law of mass action, it states that at a certain time, the speed of a chemical reaction, rate of a chemical reaction, that is directly proportional to the concentration of the particular reactants present at that time with their exponents. So, using the law of mass action, we can predict the rate of a chemical reaction if the concentrations are known. Also, we can determine the equilibrium constants or dissociation constant and other thermodynamic parameters also using the law of mass action.
Yes. What the uses of mass action?
Yes, sir. Using the law of mass action, it is the generally used for determining the equilibrium constant, that is Kp, Kc, and Kx. These types of equilibrium constant can be attained by using the law of mass action. And the law of mass action states that there will be, at a certain time, the rate of a reaction is directly proportional to the effective active masses of the reactants present at the particular time.
Yes, good.
Yes, sir.
Next one is what the relation between Kp, Kc? What the formula of Kp, Kc, and what the uses of Kp, Kc in chemical equilibrium?
Yes, sir. The Kp, that will be equals to the Kc into RT whole to the power delta N gaseous. That is the relation between Kp and Kc. To be more accurate, the relation is given as the Kp is equals to Kc into C0 RT by P0 whole to the power delta N gaseous, where C0 is 1 mole per liter and P0 is 1 atmosphere, to make the equilibrium constants unitless. And by knowing the Kp and Kc value, we can predict the direction of the equilibrium if there is a change in the shift in the equilibrium parameters. Also, we can also knowing the Kp and Kc, we can predict whether the reactants are in gaseous phase or reactants are in liquid phase. So we can predict that because it is connected to the delta Ng gaseous. There is a relation is there. So we can predict the state of the product or reactant also.
Yes, what the main role of Kp, Kc in chemical equilibrium?
Sir, it is actually equilibrium constants that are only dependent on the temperature of the particular system. So we can use the concept of the equilibrium constants to determine the different types of parameters like solubility product or pH or dissociation constant or the ionic product of water. So we can determine these types of things from the equilibrium constants, and also we can from the equilibrium constant we can calculate the electrode potential and standard electrode potential also, and also we can calculate the Gibbs free energy of a particular reaction. So these types of parameters can be calculated if the equilibrium constants Kp or Kcs are known.
Yes, you talk about the equilibrium constant. Yes, what the equilibrium constant? What the effect of temperature on equilibrium constant?
Yes, sir. The equilibrium constant that is dependent on the temperature, and equilibrium constant are those, it is a constant when temperature remains constant, and the equilibrium expression of the equilibrium constant is like that: the concentration of the product divided by the concentration of the reactant with their exponentials. These are called the equilibrium constants. And equilibrium constant are dependent on temperature, and the dependency is given as by the Van 't Hoff equation. Using the Van 't Hoff equation, we can determine whether the equilibrium constant will be increased or decreased. When the temperature is increased or decreased, it will depend on the nature of the reaction. Like if the reaction is endothermic or the reaction is exothermic, then then the equilibrium constant that will be differ in different manners.
Yes, good.
Yes, sir.
Yes, what the difference between a homogeneous and heterogeneous equilibrium?
Yes, sir. The homogeneous equilibrium, this is a type of equilibrium where all the reactants and products and the catalyst, all the things that are in same phase, then the equilibrium is called homogeneous equilibrium. And if the equilibrium, then reactant or product or some the part of the total system that is in some of them in different phase, then this is called heterogeneous equilibrium.
Yes, good. Next, other one is principle is a Lee-Chatelier principle.
Yes, sir.
What the main application of Lee-Chatelier principle?
Yes, sir. The Lassater principle, it is generally given as the it is the main statement is if the if the parameters that controls the equilibriums that is affected, then the system will react as if the then the system will try to neutralize the conditions that are affected the equilibrium. So basically, if we use the if we increase the temperature or pressure or the concentration of different species, then the system will attain a new equilibrium where it can neutralize the effect of the particulars that were affected previously. So if the concentration of the reactant is increased, then the system will try to decrease the concentration of the reactant, so it will move in the forward direction. And also if we add product, if we remove product, then there will be also they will try to produce more product, so reaction will be in forward direction. Or if we remove the product, if we add the product, then there will be a backward direction shift. So also there will be similar effects like temperature, pressure. So actually the equilibrium conditioning parameters, if they are changed, then the system will neutralize the effect that has affected before, and the equilibrium will be shifted towards forward or backward direction. So this is the main Lassater's principle.
Yes. What are the effect on Lee-Chatelier principle? How many effect?
Yes,
Factor.
sir. There are several effects. First one is the concentration. The concentration of reactant and products are altered, then there will be a shift. Also, there is a second type of effect, that is temperature effect. And there is a third type of effect is the pressure effect. And fourth type of effect, that is the addition of the inert gas. And fifth, that is the addition of catalyst. So these types of effects are there.
Yes, good. Yes, chemical equilibrium is what the beneficial point of chemical equilibrium in human life and drawback. 4 5 point.
Yes, sir. Yes, sir. The chemical equilibrium, it is a process where the a reaction when the some amount of product is formed, then the reaction will stop at the time and a equilibrium will be attained. So if a reaction does not attain equilibrium, then there will be a complete conversion of the reactant to the product. So there will not be any control to the reaction. Also in our body there are buffers. They or depend on the equilibriums. And the buffers are used for controlling the pH of our blood. So there is a requirement of the particular equilibrium to maintain the value. Also, we in analytical chemistry we use different types of titrations like gravimetric titration and other titrations also. So there is also equilibrium that is attained for the titrations, and also there is a equilibrium that is maintained for the acids and bases. That so the equilibrium, knowing the equilibrium constant, we can apply in different topics like analytical chemistry, or knowing the electrode potential, or knowing the different types of parameters which are calculated for determining the effect of a particular chemical, that is the pH and other things. So all are dependent on the equilibrium. So equilibrium is a important thing that actually drives the biological processes.
Yes, good. What the difference between chemical equilibrium and ionic equilibrium?
Yes, sir. The chemical equilibrium, it is generally used for the equilibrium between the reactant and products which are in the molecular form, and that are not particularly the chemical equilibrium is applicable for all the reactions. But the ionic equilibrium that only deals with the equilibrium of the ions that are produced in a solution phase. So ionic equilibrium is a particular type of chemical equilibrium.
Yes, good. Yeah, acid base topic we have discussed here left.
Sir, acid base is left, sir.
Yes.
Acid base titration or acid base other things?
Acid base Arrhenius, Lewis, Bronston, Lowry.
No, sir. No, sir. No, sir. No, sir. That I do not discuss.
Yes. Yes, these the part of ionic equilibrium. Yes, no.
Yes, sir. Yes, sir. Yes, sir.
Yes, acid base. What the main application of acid base?
Yes, sir. The acid bases are the useful chemical species that are generally used in different types of reaction that catalyzes the different types of reaction. So, acid catalyzed and base catalyzed different reactions are known. Acid and bases are used in different type of chemical industries, like in a battery industry, the acids are used, or in the base are used in a fuel cell. So these are the most important some parameters. Also some qualitative analysis, quantitative analysis, and other things also acid and bases are required. So they are used as catalyst or reagents, or different types of chemical species in different reactions.
Yes, first is Arrhenius concept. Yes, what the main application of
Yes, sir.
Arrhenius concept in acid base?
Yes, sir. The Arrhenius concept that states that the species which gives H plus ion in a aqueous solution, that is called acid. Example can be given as aqueous solution of HCl. So HCl is acid, it gives H plus ion. And also H2SO4, that also gives H plus ion in the aqueous solution. So these are acids in the concept of Arrhenius theory. And the bases are those chemical species which gives OH minus ion, that is hydroxyl ion in aqueous solution. So these types of chemical species are called bases. So bases, the example of bases can be sodium hydroxide, potassium hydroxide. They gives OH minus ion, hydroxyl ion in the aqueous solution. So this is Arrhenius concept of acid and bases.
Yes, any drawback limitation of Arrhenius concept?
Yes, sir. It only deals with the acid and basic strength, in acid and bases in aqueous solution only. So in gaseous phase, acid base reaction that cannot be explained by the Arrhenius theory. Also, there are some acids like BF3, aluminum chloride. They are also acids, but they cannot be explained from the Arrhenius theory. Ammonia is a base, or alkyl amines are, or 2-degree amines, that are also bases, but that cannot be explained from the Arrhenius theory. So Arrhenius theory only deals with the acid and bases in the aqueous medium only.
Yes. Next one is Bronston-Lowry concept. Yes,
Yes,
what
sir.
is Bronston-Lowry concept?
Yes, sir. The Bronsted-Lowry theory, it is called a protonic theory because it only deals with the transfer of proton in acid-base reaction. According to Bronsted and Lowry, a acid is a species which gives the proton, and the base is a chemical species which accepts the proton in a chemical reaction. So these are called Bronsted and Lowry theory of acid and bases. So if in a reaction like the reaction of HCl with ammonia, then the H plus ion, that is the proton that is given by the HCl. So HCl here acts as a acid, and ammonia is accepts the proton, so it acts as a base.
Yes, good. Next one
Yes,
is
sir.
Lewis acid base concept.
Yes, sir. So the Lewis acid base concept, it is called the electronic theory of acid and bases. The Lewis theory, it states that the base is a chemical species the electron pair that will be in lone pair or negative charge. So these species are called bases, and the species that accepts the electron pair that are called acids, and that are called Lewis acid. So a reaction can be given as the reaction of ammonia with the BF3. In the reaction of ammonia with BF3, the lone pair of the nitrogen that is given by ammonia and boron, due to its sextet of electrons, it accepts two electrons to fill their octet, and so it accepts the electron. So BF3 is a Lewis acid and ammonia is a Lewis base here, and the reaction is called Lewis acid base reaction, and the product formed after the reaction is called Lewis acid base adduct.
Is what the example of Lewis acid base?
Yes, sir. Lewis acid are different types of acids are there, like boron trifluoride BF3, aluminum chloride AlCl3, FeCl3, ZnCl2. So these are examples of Lewis acids. And Lewis bases example will be ammonia, alkyl amines, water, or different types of aromatic nitrogenous species. So these can be given as the example of Lewis bases. Phosphine.
Yes, good. Next one, new
Yes,
topic
sir.
is pH. What is pH?
Yes,
What
sir.
is the application of pH? Describe.
Yes, sir. The full form of pH is the potence of hydrogen ion. The potence, it is a German term that is actually predicts the power of the hydrogen ion. And using pH, we can predict the whether the solution is acidic or basic or neutral. So the nature of the solution that can be predicted by the pH. And knowing the pH that are widely applicable for the dilute solutions. By knowing the pH, we can carry out different types of reaction in a particular pH. So there are several reactions which is dependent on the pH. So knowing the pH, it is very much important for the controlling the particular reactions. Also, they are in different industries, the pH is controlled by using the buffer solution. So there are the uses of pH for calibration purpose. Also in the agricultural point of view, when in the fisheries they measure the pH of water to for the best growth of the fishes. And also the pH is calculated for drinking water. Also the pH is calculated for acid rains and other things, whether that will be harmful or not, that can be predicted by knowing the pH value of the particular species.
Yes, what is common ion effect?
Yes, sir. The common ion effect, it is a effect where if there is a weak electrolyte is present, and there is any common ion, that is either the cation or the anion, that are present in the solution in excess amount. If we use another common ion, then the dissociation of the particular weak electrolyte that will be decreased. That is, the equilibrium will be shifted towards the left direction. So this is called common ion effect. Due to common ion effect, the dissociation of the particular weak electrolyte that will be decreased in a large extent.
Yes, what the formula for strong acid and strong base in aqueous solution from pH
Yes, sir.
and pOH? Determine.
Yes, sir. For the strong acid and strong bases, pH can be directly calculated by knowing the concentration of the H plus or concentration of the OH minus. The formula is given as pH is equals to minus log concentration of H plus and POH is equals to minus log concentration of OH minus. So for strong acid and bases, pH and pOH can be calculated easily.
What is buffer solution?
Yes, sir. The buffer solution are those solutions that register change of pH when there is a addition or there is a slight addition or addition of acid or bases. So they basically do not change their pH when some amount of acid and bases are added. So these types of solution are called buffer solution. Their pH remains same after the addition of the acid or base.
How many type of buffer solution? What the example?
Yes, sir. Yes, sir. There are generally the most buffer solution. One is called acidic buffer and one is called basic buffer. The acidic buffer that is consist of the weak acid and its salt, and the basic buffer that contains the weak base and its salt. Though there are also different types of buffer like a salt of two salts of a polybasic acid like sodium NaH2PO4 and Na2HPO4 that can be used as a buffer. Also, if there is a strong acid that is in concentrated form, that also can act as a buffer. Also, the salt of a weak acid and weak base that can also act as buffer. Also the solution of a weak acid that also can act as a buffer. But there are main two types of buffers. One is acidic buffer and one is basic buffer. The acidic buffer is generally made by the weak acid and its salt, and the basic buffer is made by weak base and its salt.
Is what the example of acid or base buffer? Example.
Yes, sir. The examples of acid buffers are acetic acid and sodium acetate solution, and the example of basic buffer is the ammonium hydroxide and ammonium chloride mixture.
Yes, good. Now, how to determine
Yes, sir.
pH determination of basic buffer solution? What the formula? pH
Yes, sir.
determination of
The
basic buffer solution.
Yes, sir. The pH of the buffer or pOH of the buffer that is calculated by using the Henderson equation. And the Henderson equation for acidic buffer is pH is equals to pKa plus log salt by acid. And the buffer and the Henderson equation that is used for the basic buffer, that is pOH is equals to pKb plus log concentration of salt by base.
Yes, you talk about the Henderson
Yes,
Hassel
sir.
equation. Yes, what the main application of these equation in acid base?
Yes, sir. That is mainly used for determining the pH of a particular buffer solution. And generally, we use the buffer solution for calibration purpose or different in analytical chemistry. So we have to make the buffer solution of a particular pH. So to know the pH of the buffer, that should be very much important to determining the pH of the particular buffer. So generally we take the acid that has a similar pKa value, which we want to the pH of the solution that should be nearly the pKa value of the acid. And also if we want to make a basic buffer, then the pKb value should be nearer the pOH value of the particular buffer, and then we can adjust the concentration of the acid and concentration of the salt, or concentration of base or the concentration of the salt, that can we can adjust to make the exact pH that is required.
Yes, good. And what are the effect of temperature on pH, pOH, and pKw of water molecule?
Yes, sir. As the dissociation of the water, that is a endothermic process. So
Yes.
on increasing temperature, the dissociation of water increases in a large extent. So the Kw, that is the ionic product of water, that increases with the increase in the temperature. So the pKw, that is the minus log of Kw, that decreases in that increase of temperature. So the pH range that shrinks in with the increase in the temperature. So the at the 25 degree, there the 7 pH that is considered as neutral, but as the at 100 degree centigrade, there will be the shrink in the pH. So 7 pH that will be under the basic region of the particular pH range. So there will be less than 7. The pH of the neutral solution that will be less than 7 in case of at 180 degree, because Kw will be higher and pKw will be lower. So the range of the pH that will be shrinked, and exact value for the 100 degree centigrade for neutral water, that is 6.13. So the 6.13 will be neutral water, the less than 6.13 pH that will be for acidic, and more than 6.13 for the pH that will be used for the basic solution.
Yes, on increasing the temperature, so what will be the effect on pH value? Value something less than 7 or more than?
Sir, pH of neutral water.
Yes, water molecule. Yes,
The
neutral.
pH, yes, sir. The pH of neutral water, that will be less than 7.
And pOH value, increase the
The
temperature.
pOH, sir, if we increase the temperature, so pOH value that will be greater than 7.
Yes.
Yes, sir.
Is what the example of hard acid, hard base, soft base, HSAB principle.
Yes, sir. The hard-soft acid-base principle, it states it actually categorizes the acids and bases in the hard, soft, and borderline condition. The hard acid are those acids which have a high charge and less radius, so the charge density is very high. These are considered as hard acid. And the soft acid are those acids which have a charge by radius, that is ratio, that is less, that are called soft acid. And the middle types of these two acids are called borderline acids. And for the bases, if the size is small and the charge is higher, so these types of bases are called hard bases. And if the charge is lower and the radius is higher, these types of bases are considered as the soft bases, and middle of two are called borderline bases. And the hard soft acid base principle states that the combination with the hard and the soft that will be more stable compared to the combination of hard soft type of acids or bases. So HSAB principle states the stability of the hard combination and soft combination, and the product will be more stable.
Yes, good.
Yes, sir.
Next one is acid base indicator. First of all, what is
Yes,
indicator?
sir. Yes, sir. The indicator, it is a chemical species which actually which actually indicates us the end point or the equivalence point that are by changing its color. These are called indicators. And in case of specific acid base indicator, the indicators are generally weak organic acid and bases. They can remain in two different types of forms, and depending upon the pH, and in the change in the pH after the equivalence point, the state of the particular species changes, and so the color of the particular species also changes, and we can predict the equivalence point or end point betterly.
Is what the example of acid base indicator?
Yes, sir. There are several. One is phenolphthalein, one is methyl orange, methyl red, bromothymol blue. So these types of examples are there.
Yes, good. Next one is acid base titration and used of indicator. What are the uses of acid
Yes,
base titration used in indicator?
yes, sir. In case of acid-base titration, the titration are of four types. One is the titration of strong acid and strong base. The second one is the titration of strong acid and weak base. The third type of titration is weak acid and strong base, and the fourth one is weak acid and weak base. So for different types of titration, the change in the jump in the pH near the equivalence point, it is different types. In case of strong acid, strong base, there is a sharp change in the pH. The pH jump, it is from 4 to 11. And for the weak acid, strong base, there will be a jump between the 7 to 11 or 7 to 10.5. approximately. And for the weak acid, for the strong acid and weak base, the pH jump is from the 4 to 7. So the indicator which has a indicator range in between the particular jump in the pH that shows the color by changing its different composition, different chemical form. And for generally strong acid and strong base, all the indicate generally most of the indicators changes the color in the particular range. So in case of strong acid strong base titration, any type of indicator can be used. But for strong acid and weak base, as there is a pH change from 4 to 7, so sharp change from 4 to 7, so there will be the uses of generally methyl orange is there. So methyl orange, the orange has the indicator range in between the particulars. And in case of the weak acid and strong base, there will be a sharp change in pH from 7 to 11 takes place. So generally we use the phenolphthalein to determine the particular endpoint. But as the weak acid, for the weak acid and weak bases, no sudden jump in the pH or change in the pH is observed. So no particular indicators are there for the titration of weak acid and weak bases.
Yes, good. Next one question is solubility product in acid base. Yes,
Yes,
describe what
sir.
the application of solubility product and what the uses of solubility product in acid base. Describe one by one.
Yes, sir. The solubility product, it is generally used, the term that is used generally for the sparingly soluble salts. The sparingly soluble salts are those salts which has very less solubility in the water. That is the 0.0, highest concentrations would be 0.01 molar. So these types of salts are called sparingly soluble salts. So they are, if the concentration of the ions are more than that particular, then there will be a precipitation formation. So if the ionic product of the concentration of the two cations and anions, then if that is greater than the Ksp, that is solubility product, so precipitation will occur. So by knowing the particular Ksp, that is solubility product, we can predict whether a precipitation will be there or not for a particular chemical species. Also using this phenomena, there are several applications. One application is the purify of the sodium chloride. That is they are by the using this concept. In case of sodium chloride, we actually take the impure sodium chloride, saturated aqueous solution of impure sodium chloride, and we blow into the solution. HCl gas is blown into the solution, so there will be the increase in the Cl minus ion, and so precipitation of pure NaCl should be there, and we can purify the NaCl from the impure NaCl. Also we can precipitate the soaps in a solution, because the soaps, they are in the colloidal form. So if we add some extra NaCl, then there will be the excess sodium plus ion, so there will be the precipitation of the soap. So the precipitation of the soap, that is done by the concept of these. Also in some qualitative analysis, that is the concept of the ionic concept of the solubility product that is used, and we divide the particular ions in different groups depending upon the reagents that are required for the precipitation of the reaction. So these are some applications of solubility product.
Yes, good. The last two question: what the beneficial point of in our society ionic equilibria? Any 4 5
Yes,
points
sir.
and the drawback.
Yes, sir. It is the most important, one of the most important chapter in a physical chemistry, because by knowing the concept of the ionic equilibrium, we can make several different types of things like buffer or indicator or other things. So in knowing the concept of the buffer, we can use in different types of qualitative and quantitative analysis also. We can resist the pH. In our body there is a buffer, that is bicarbonate carbonic acid buffer or phosphate biphosphate buffer, that are used to make the blood pH of the blood constant. So that are in the very much important for our biological process. Also knowing the concept of the ionic equilibrium, we can predict whether there will be a precipitation or not, like the pure NaCl that is prepared from the impure NaCl. Also, these are used for qualitative analysis. That is, we can predict the presence of a particular ion in a solution. So these are some useful applications of the concept of ionic equilibrium.
Yes, good.